Hi everyone, welcome back to the channel and to episode 4 of the shed build. If it's your first time, welcome, and why not consider subscribing. So this is my old shed and this is where I'm up to building the new one. Now I had to make a choice of either filming everything and not having enough time to build what I needed, or build as much as I could in the week in August that I had off at work. So unfortunately that's what I had to do. I've covered it as best as I can, and any questions you've got please ask and I'll do my best to answer for you, or I'll even do a video explanation if needed. Remember, I'm not a builder, I'm a dad, and I did this with no previous experience, so if I did you can too. So let's get started. So I left off in the last video with the first course of bricks and the concrete floor being poured. I then set the further 2 courses starting at the corners to ensure level lines along all the walls. In the UK, in damp climates, your enemy is water and damp with a new shed, or any shed for that matter, so you need to get the timber structure off the floor and in some way out of the damp. Also, you need to think about moisture escape once inside the shed, such as if you think about condensation from just someone in there breathing. If I give the analogy of if you're in a car on a winter's day and all the condensation building up on the windows of your car, well, that'll be the same sort of thing inside your shed, so you've got to give some consideration to sort of air circulation. As with the floor course, I used engineer bricks for the small wall that I built for the shed to sit on, because these only transfer something like 7% moisture. With the bricks complete, I tidied up the edges with a pointing trowel and brush, and then after I'd tidied these joints up, and really that was just to make it look better and a little bit nicer when inside the shed. Once I'd cleared up the area, I then set 15cm coach bolts upside down into the circular holes in the engineering bricks, and I set them in with cement with enough thread poking up so when I put the framing onto the brick wall, the thread was sufficient to be able to just poke through the top of the wood and let me get a washer and nut on the top of that. I used a small set square to ensure that the bolts were square from the side and front, because if there was an angle on them it would have caused problems lifting the framing onto the bolts themselves. I used a sliding miter saw for a lot of the build. It's a savage tool but a massive time saver, so if you don't have one for your build, consider some of your build budget in buying one or borrow one from a friend. After the first delivery of wood, I started building the frame with butt joints and 100mm or 4-inch screws, and used 2 on every joist. I built the frame on the floor for ease and used 2x4 timber which was treated. You can see there I also added a damp course to prevent any moisture transfer from the bricks into the framing. I used self-countersinking, self-drilling screws. I had to fully build the back wall because of its proximity to the back fence. It took 3 of us to lift it once it was built and bolt it up in place. I had to brace it to a tree once it was in place to enable me to keep it there whilst I built the existing framing. Don't underestimate the weight of a fully built wall, it was heavy. And there's the bolts in place with a penny washer on top, and that's just enough thread poking out. The UPVC door I used was a wide width disabled access door which was second hand, and I think it cost me about £20. I also installed a nearly new UPVC window that I was given for free from a colleague at work. Thank you very much, Tony. Both of these were screwed directly into the framing. These were the structural screws I used for the framing, and I think they were about £6 for a box of 100. I wrapped the frame in a breathable membrane which was on this occasion Tyvek house wrap. I bought a half roll which was part used for £30 second hand. Well, it wasn't second hand, but somebody had already used part of it. It prevents water getting into the structure, but it breathes, so if some does get in, it can get out. The outside of feather edge cladding I used was 175mm by 30mm cladding. All of it was painted by my wife, so thank you very much, wifey, for that. There was only a couple of mishaps with screws, and that was generally when the wood had completely dried out. So in the 2 occasions where it did split, I glued and clamped that to save having to buy another 4.8 metre length. The roof joists were 2 by 5 inch thick joists, which I checked building regs for the span to prevent bowing. I needed to ensure I chose the right thickness of wood because I didn't want the roof bowing over time. These were fixed with hangers on the back wall, and then on the front wall they were bird beak notched and then screwed to the front. I used OSB board for the roof sheeting on the top, and then a roofer friend of mine helped me install a 2-stage domestic house grade flat roof which should last 25 years. That consisted of a underlay and a top bitumen coat which was heat bonded to the underneath layer. Big thanks to my friend Paul for helping me with the roofing side of things. I wouldn't have been able to have achieved the quality roof that I had done without his assistance. So the structure is up, the roof's complete, it's watertight, all the cladding's on, and door and window is fitted. The next episode will be the interior fix, insulation installation and the fit out plans. Thanks for watching, please subscribe if you haven't already, and I'll see you on the next video.